Question 90. ABC is a right angled triangle. AB is 9.3 centimeters, correct to the nearest millimeter. So you can see it's already there. Let's just write what the error interval for this one would be. So the error interval is the original number plus and minus the limit of accuracy divided by 2. Here, the original number is 9.3. Because it's to the nearest millimeter, let's just think, how could we write millimeters in centimeters? So I know 1 centimeter is equal to 10 millimeters, but I just want 1 millimeter because I'm rounding it to the nearest millimeter. So if I divide this by 10, I get 1 millimeter. That would be 0.1 centimeters. So I'm rounding it to the nearest 0.1 centimeter. So I'm going to do plus and minus 0.1 divided by 2. So that's 9.3 plus and minus 0.05, which is equal to, I'll do the smaller one first, 9.25 is my lower bound, and my upper bound, 9.3 at 0.05 is 9.35. AC is 12.6 centimeters, correct to the nearest millimeter. So I'm going to do the same thing with this one. 12.6 plus and minus 0.05 is equal to, that'd be 12.55 lower bound, 12.65 for the upper bound. Calculate the lower bound for the size of the angle marked X. I'm trying to find the smallest possible angle this could be. Show all your working. We know we're going to be using trig here. Let's first label our sides. We've got the side opposite the right angle, which is the hypotenuse. The side opposite the angle, which is the opposite. So I only need these two. So which ones from Tutor are we going to be using? We're looking for O and H, so that's going to be sine. It's going to be sine, the inverse sine, because we're trying to find an angle of the opposite over the hypotenuse. So it's O over H. And let's just have a think about this. We're trying to get the smallest possible angle, so we're going to have to try and get this as small as possible. And if you're not sure whether you're trying to maximize this or make this as small as possible, you could just try two different values and substitute in and see which gives you the smaller one. Does the big one give you the smaller angle, or does the smaller one give you the smaller angle? So I'm trying to minimize this value, O divided by H. So for my numerator, I want a really small number, and I want to divide it by something as large as possible. So I'm going to choose my lower bound for my opposite, which is AB. I'm going to choose my upper bound for my hypotenuse, which is AC. So the inverse sine of the lower bound of my opposite, which is 9.25, that's that one. And I'm going to use my upper bound for my hypotenuse. So that's 12.65. Just type that in. So the inverse sine of 9.25 over 12.65. And that gives me 46.9892. I'll just round this to one decimal place. So I'm looking after the 9. That 8 is telling me that I need to round up. So that's going to go to a 0, and I need to carry 1 into my unit. So it's going to become 47.0, and that be in degrees to one decimal place.